Hello all, my name is Parmita.
This is Amrita Varshini from class 9A. Today we both will be giving a small introduction about our class topic gravity, space centrifugal and centripetal. Centrifugal. Centrifugal is the apparent outward force on a mass when it is rotated. For the rotating earth, centripetal force is supplied by the gravitational force towards the earth's center. Now, let's see a video to know more about it.
Hello to all. My name is Dhriti Ganesh of class 9A, and today our group is going to be explaining centrifugal force. I'm going to be giving a brief explanation or intro about this force, and my group members Kavya, Jyotsna and Pranesh are going to be following up. Centrifugal force is the apparent force felt by the object moving in a curved path that acts outwardly away from the center of rotation. It is viewed from a rotating frame of reference. Now, my group members are going to be giving a more deeper explanation on what this type of force is.
I'm Kavya from class 9B. What is centrifugal force? In Newton mechanics, the centrifugal force is a force that appears to act on all objects when viewed in a rotating frame of reference. It is directed away from an axis which is parallel to the axis of rotation and passing through the coordinate system's origin. Centrifugal force is the apparent outward force on a mass when it is rotated. Centrifugal force is characterized by an orientation pushing the body outwards. Example of centrifugal force: a vehicle driving around a curve on the road. Thank you.
Hello everybody, this is Jyotsna from class 9A. Formula for centrifugal force. Centrifugal force is directly proportional to the mass of the object and square of the velocity. It is inversely proportional to the square of the distance between the center and the object. As you can see the picture to the right, F represents centripetal force, M represents mass of the object, V represents velocity of the object, R represents radius of the circle, and A represents acceleration due to circular motion. From the above formula, we can find that it is to calculate the centrifugal force. We can see from the formula how the velocity of an object is an important factor for generating the centrifugal acceleration. If angular velocity is known, then the centrifugal force can be calculated using the formula given below, where the symbol is an angular velocity. How is centrifugal force calculated? Centrifugal force formula is given as a negative product of mass in kilograms and tangential velocity in meter per second square divided by radius in meter, which implies that on doubling the tangential velocity, the centripetal force will be quadrupled.
Hey folks, Pranesh here from class 9B, and I'll be talking about the day-to-day applications of centrifugal force. When a car is in motion and it takes a sudden and a hard turn to the left, the passengers in the car, you for example, will experience an outward push to the right. This is because of centrifugal force acting upon you. A bucket filled with water is rotated in a vertical circle at a particular speed so that the water does not fall. We can take this as a washing machine example. This water is rotated in a vertical circle at a particular speed because the weight of the water is balanced by the centrifugal force acting upon it, which prevents the water from falling. And you might have experienced this one if when you were a child. You might have experienced an outward pull as you go around the merry-go-round when it rotates about its vertical axis. This is due to the centrifugal force acting upon you and a couple fellow mates with you maybe. The bulging of the earth at the equator and the flattening at the pole is also due to the centrifugal force acting upon it. like pendulum in both stationary and rotating. Real pendulum. The solid deposit not must moving against caution. Okay.
Good morning, everyone. My name is Ashwin, and today our topic of discussion is artificial gravity. My two team members are Aryan and Ananda Lakshmi. So let's get started. Aryan, to you.
Okay, so the artificial gravity, we have a video which was prepared by Ashwin. So artificial gravity is our topic. So what is artificial gravity? So artificial gravity is the creation of an inertial force that mimics the effects of a gravitational force, usually by rotation. Artificial gravity is created in what we call artificial gravity generators. They are used for training astronauts in the zero gravity. So this is an artificial gravity generator. It's a diagram actually. It was created by Anand Lakshmi. So she would like to explain it. Over to you, Anand.
A artificial gravity generator is based on concept of centripetal acceleration. When the wheel spins due to the rotation, the acceleration increases, making the people inside experience gravity due to the interpersonal activity.
It is very similar to Earth rotating about its axis. Since Earth and every planet in the solar system move in rotational motion, we can say that Earth moves in an accelerated motion. Hence, acceleration is equal to gravity, because of which we can stand in the ground. To you,
Thank you,
Aryan.
Ashwin. So this is an experiment theoretically explaining anti-gravity. The cardboard in hand are held in between a total of 6 magnets placed in such a way that the magnets will be repelling each other and theoretically the sheet will hover. So in simple words, it's actually two cardboard sheets cut out in triangular form. There are totally six magnets, two on the both ends, on the very both ends, and two in the middle. So that is the north side of the top magnet and the north side of the southern magnet. That makes it repel. So that's what we have explained over here. So now Ashwin will be explaining some examples of artificial gravity.
One of the most simple examples of artificial gravity is the monorail. The wheels of the train are replaced by magnets, whereas the rails are made up of unlike magnets. When a train is running on the rail, the unlike magnets of the wheels and rails repel, making the train hover slightly above the ground, thus enabling it to travel in very high speeds. Artificial gravity generators are slightly hard to create as they are expensive and require the skill for it.
So now are some facts of artificial gravity which will be explained by Anand. Over to you, Anand.
Gravity makes waves that move at light speed. Gravity is by far the weakest force we know. Gravity might be carried by massless particles called gravitons. Explaining the microscopic behavior of gravity has thrown researchers off for a loop. Gravity and weight are not same thing.
Thank you, Anand Lakshmi. So that was the
Thank you.
presentation artificial gravity. Thank you.
Hello everyone, my name is Vaibhav Pathak from class 9th A, group number 3. Topic Artificial Gravity. Artificial gravity. to make artificial gravity, first we need to know what is gravity. Google says it's a force applied on an object to pull it towards the center of the earth. So, does gravity lie in the center of the earth? Technically, yes. See, the earth revolves around the sun. That is, it spins and spins around the sun. Spins and spins. So, it creates a force known as centrifugal force. And then, it doesn't let things fly off of it. Or else, I would be making this video on Pluto or something like that. It's easy that centrifugal force is gravity. For example, one experiment. So, as you can see, in this experiment, a young boy, mostly idiotic, comes and tries to be Hrithik Roshan, spins it as fast, and the water doesn't fall. Miracle. I need to see a therapist. So, as you saw in the experiment, a glass of water filled to the brim didn't fell. Why? Because it was on its own gravity. That is, we had made artificial gravity. For just a minute, but we had made. So same applies with the earth. The earth spins around the sun in the same way the glass of water did. And as it has its own gravity, it doesn't come towards the sun same way the water did. So that proves that artificial gravity is possible by mankind. There's one more way, and it's known as magnetism. So magnetism is not a new concept for us. In fact, we have been learning magnetism since 6th grade. So, magnetism is when a magnetic force pulls something towards it or away from it. That is known as magnetism. This experiment shows that it is possible, and it's easy. The magnets at the side connect each other, and the magnets at the middle repel, and this is known as magnetism.
Good morning all, my name is Naveen and today we are going to talk about spacecrafts. So what are spacecrafts? Spacecrafts is a vehicle used for traveling. There are a lot of different spacecrafts like flyby spacecrafts, orbiter spacecraft, atmospheric spacecraft, lander spacecraft, penetrator spacecraft, rover spacecraft, observatory spacecraft, communications and navigation spacecraft. I have named some and you will see the explanation of the spacecrafts in this following video.
Hello everybody, this is Rohini of class 9A. Today I am going to talk about spacecraft. Spacecraft is a vehicle designed to operate in a controlled flight pattern above Earth's lower atmosphere. This is a model I have made for you to have a clear idea how the spacecraft will be. The first spacecraft was the Soviet Union's Sputnik, which was launched by Russia on October 4, 1957. Spacecraft helps in many ways. It helps us to know about the daily weather forecast, communication. It also helps us to research about the mysterious things takes place in space, like the aliens and black holes. And last but not the least, it helps us to know about the celestial bodies present in the space. I hope you have learned something new and interesting and liked my presentation. Thank you and have a nice day.
Hi all, my name is Shobita and I am from class 9B. Here is my model of another spacecraft. Now that you know what a spacecraft is and its uses, let me go ahead and explain its parts. A nose cone is a conically shaped forwardmost section of an aircraft designed to modulate oncoming airflow behaviors and minimize aerodynamic drag. The forward fuselage consists of the upper and lower fuselages. It houses the crew compartment and supports the forward reaction control system module, nose cap and the nose gear related parts. The payload bay doors are hinged along the side and split at the top center line, that is, that one door per side 18.3 meters long. Each side consists of the four 4.6 meter segments that are interconnected through expansion joints that allow the door to act as one 18.3 meter door. The orbit maneuvering system provides the thrust for orbit insertion, orbit circularization, and orbit air transfer that can provide up to 1,000 pounds of propellant to the aft reaction control system. Regarding the vertical stabilizer and rudder, the orbiter's vertical stabilizer, which is like a fin, has a rudder which controls its yaw, nose left and nose right, and the split rudder also works as a speed brake. It does this by splitting it in half vertically and opening like a book. Above the aft fuselage, it consists of a left and the right orbital maneuvering systems, space shuttle's main engines, body flap, vertical tail, and external tank rear attachments. The forward bulkhead closes off the aft fuselage from the mid fuselage, and the upper portion of the bulkhead attaches to the vertical tail. The ailerons or ailerons are the aircraft control surfaces that combine the functions of an elevator used for pitch control and the aileron used for roll control. They are frequently used on tailless aircraft such as flying wings, and an aileron is not a part of the main wing but instead is a separate tail surface that acts as a stabilizer. Hope you all understood my description regarding the parts of the spacecraft. Thank you and have a wonderful day.
Unidentified flying object UFO, also called flying saucer. Any aerial object or optical phenomenon not readily identifiable to the observer. UFOs mainly became a subject of interest following the development of rocketry after World War II, and were thought by some researchers to be intelligent extraterrestrial life visiting Earth. The phrase was coined by an acronym by Project Blue Book, Project Head Edward J. Belt. But today, UFO is widely used as a stand-in for extraterrestrial spacecraft claimed to be observed by various people. Many UFOs are described to be flying saucers. This is one of the early UFOs seen by people. This is a replica of it. This is what people said they saw. Thank you.
Thank you for watching. There is still a lot to discover in this universe, but thanks to the man-made objects we built, we can discover a lot of things. Thank you.
Good morning. Hi, I am Mukesh, and today we are going to see about spin launch. And our group members are myself, Mukesh, Meda, Nigamant, and Havedani. Havedani will begin. Thank you.
Good morning. My name is Havedini, and I'm going to explain about spin launch. Spin launch is a stealth space catapult startup. This aims to create cheaper and sustainable way to get satellite from Earth into space without any chemical problem. Finland provides dedicated orbital launch with high frequency at a magnitude lower than any nature launch system. Finland uses a centrifuge spinning at an incredible rate inside a vacuum. A chemical rocket would come when once the payload has been launched from the ground system. Next, Medha will continue about the spin launch company.
Hi, I'm Neetha, and I'm going to be talking about the company Spin Launch. Spin Launch is an aerospace company founded by Jonathan Yenny in 2014 in the city of Sunnyvale in California. The company aims to launch satellites into space without a traditional launch pad and develop a low-cost launch system. Jonathan and the entire team of Spin Launch completed their first real centrifuge in 2016 and aim to begin commercial launch in 2022. Now, Nigamant will explain on how spin launch works.
Hi, I'm Nigamant. I am going to explain how does spin launch work. This technology uses a vacuum sealed centrifuge to spin a rocket. It has a kinetic launch system with an internal vacuum chamber with a diameter of 100 meters. The goal of significantly lowering the cost of access to space while increasing the frequency of launch. After it reaches 5,000 miles per hour, the rocket then ignites its engines at an altitude roughly around 61 kilometers. To reach orbital speed of 17,500 miles per hour, it can carry up till 5 satellites. If successful, this acceleration concept is projected to be both lower cost and to use much less power, with the price of a single space launch reduced by a factor of 20 to under 5 lakh USD. Thank you. Have a nice day.
Greetings, my name is Matangi. Today, my team and I are here to present you about our topic rotating space. In this presentation, we'll be covering the topics what is rotating space, history of the space station, principles, and why the space station has a rotating wheel by Raghav, Samiksha, Sarvesh, and Matangi.
Hi, what is a rotating space station? What is rotation? So rotation is a commonly observed phenomenon. Stars, planets and similar bodies all spin around on their axis. Rotation rate of planet in the solar system was first measured by tracking visual features. Forces associated with the rotation of Earth cause the planet to be slightly oblate, displaying a bulge at the equator. The moon's gravity primarily and to a lesser degree to the sun gravity act on Earth's oblateness to move the axis perpendicular to the plane of Earth orbit. Next. What is space station? A space station, also known as an orbital station or an orbital space station, is a spacecraft capable of supporting a human crew in orbit for an extended period of time and is therefore a type of space habitat. It lacks major propulsion or landing system. Station must have docking ports or allow other spacecraft to dock to transfer crew and supply. As of 2021, there is one fully operational and permanently inhabited space station in low Earth orbit, the International Space Station ISS. China's Tiangong space station is under construction. Both India and Russia have proposed to build stations for the coming decades.
Rotation and space station related.
Let me explain. So, rotating wheel space station, also known as a donut or von Braun wheel, is a concept for a hypothetical wheel-shaped space station. So, moving on to Sarvesh.
Everything in this world has a history like coins, buildings, etc. I wonder what is the history of space station?
Yeah, I will explain. A rotating wheel space station is also known as a donut city or a von Braun wheel is a concept for a hypothetical wheel-shaped space station. It was originally proposed by Konstantin Tsiolkovsky in 1903. The idea was expanded by Hermann Potovnik in 1929. Konstantin Tsiolkovsky wrote about using rotation to create an artificial gravity in space in 1903. Hermann Potovnik introduced a spinning wheel station with a 30-meter diameter in his problem Der Befreiung des Weltraums. the problem of space travel. He even suggested it be placed in 1950s, Werner von Braun and Willy Ley, writing in Collier's magazine, updated the idea, in part as a way to stage spacecraft headed for Mars. They envisioned a rotating wheel with a diameter of 76 meters, which is 250 feet. The three-deck wheel would revolve at 3 rpm to provide an artificial one-third gravity. It was envisaged as having a crew of 80. In 1959, a NASA committee opined that such a space station was the next logical step after the Mercury program. The Stanford Torus, proposed by NASA in 1975, is a enormous version of the same concept that could harbor an entire city. Over to Matangi.
Everything is related to science. We even learnt about rotation in science. I was just wondering, what is the principle of this wheel?
Principles of rotating space station. What is a space station? A space station is a large artificial satellite used as a long term base for manned operations in space. Rotating wheel space station. A rotating wheel space station is a concept for a wheel shaped space station. It creates artificial gravity by its spin. It is also known as a von Braun wheel. Principles. Such a station would rotate about its axis, thus creating an environment of artificial gravity. Occupants of the station would experience centripetal acceleration according to the following equation. A is equal to minus w square r, where w is the angular velocity of the station, r is its radius, and a is linear acceleration at any point along its perimeter. In theory, the station could be configured to simulate the gravitational acceleration of Earth, 9.81 meter per second square, allowing for human long stays in space without the drawbacks of microgravity.
Why do space stations have a rotating wheel?
Let me explain. First of all, for learning why do they have a rotating wheel, we have to see why do space stations rotate. A rotating wheel provides artificial one-third gravity. Artificial gravity can be created using a centripetal force. Generally, a centripetal force is directed towards the center of the turn and is required for any object to move in a circular path. In this case of a rotating space station, it is normal force provided by the spacecraft's hull that acts as centripetal force. What is the hull of the spacecraft? The hull is a body or the main structure of a starship, starfighter, or a vehicle. It could hold crew, passengers, cargo, weapons, engines, or other components necessary for the operation of the craft. Thank you, and I hope you all enjoyed this presentation on the donut city or the Von Braun wheel.
Thank you.
Hello, my name is Kamali of Class 9. The topic given to us is the gravitational waves. This PPT is done by Nithilan, Shreyas and myself Kamali. What are gravitational waves? First of all, what do you mean by gravity? We know that the force that attracts a body towards the center of the earth or towards any other physical body having mass. Gravitational waves are ripples in space-time. When objects move, the curvature of space-time changes and these changes move outwards as gravitational waves. A gravitational wave is a stretch and squash of space and so can be found by measuring the change in length between two objects. They travel at a speed of light. Their strength weakens proportionally to the distance travels from the source. What can we learn from gravitational waves? So, gravitational waves are a new way of observing the universe. Astronomy traditionally used light to explore the cosmos, but there are lots of things you can miss because a lot of the universe is dark, including black holes. One source of gravitational waves is two dense objects, like black holes or neutron stars, in orbit around each other. Who found gravitational waves? They were proposed by Henry Poincaré in 1905 and subsequently predicted in 1916 by Albert Einstein on the basis of his general theory of relativity. Gravitational waves transport energy as gravitational radiation, a form of radiant energy similar to electromagnetic radiation. Basically, Einstein theorized the existence of gravitational waves 100 years back, but we have proved it only recently.
Einstein's theory of gravitational waves. The existence of gravitational radiation is natural prediction of in any relativistic description of the gravitational interaction. First, they introduce those mathematical concepts that are necessary to properly formulate the physical theory, such as the notions of manifold, vector, tensor, metric, connection, and curvature. Gravitational waves are later introduced as solutions of the linearized Einstein equation around the flat spacetime. These waves are shown to propagate the speed of light and to possess two polarization states. Gravitational waves can be interact with matter, allowing for the direct detection by means of laser interferometers. Finally, Einstein's quadrupole formulas are derived and used to show that non-spherical compact objects moving at relativistic speeds are powerful gravitational wave sources. There are four types of gravitational waves. Continuous gravitational waves, which are produced by systems that have a well-defined frequency. Compact binary inspiral gravitational waves, which are produced by orbiting pairs of massive and dense objects. Burst gravitational waves, which are produced from short duration or unknown or unanticipated source. Stochastic gravitational waves, which are really gravitational waves from the early evolution of the universe.
Continuous gravitational waves. Continuous gravitational waves are produced by systems that have a fairly constant and well-defined frequency. Examples of these are binary system of stars or black holes orbiting each other in long before merger, or a single star swiftly rotating about its axis with a large mountain or other irregularity on it. And this is the picture of continuous gravitational waves. Compact binary inspiral gravitational wave are produced by orbiting pairs of massive and dense compact objects like white dwarf stars, black holes, and neutron stars. There are three subclasses of compact binary system in this category of gravitational wave generators: binary neutron star called BNS, binary black hole called BBH, neutron star black hole binary called NSBH. Burst gravitational waves. Burst gravitational waves come from short duration, unknown or unanticipated gravitational waves that go bump in the night. The sounds these gravitational waves are expected to produce are pops and crackles, and it is difficult to say since very little can be assumed of their origins. Stochastic gravitational waves. The really gravitational waves come from the early evolution of the universe are called stochastic gravitational waves. Similar backgrounds could be produced by a combination of many simultaneous inspirals, burst or continuous signal from throughout the universe. And this
Hi, I'm Renali from class 9B and I'll be talking about fun facts about gravitational waves. Gravitational waves were first predicted by Albert Einstein 100 years ago. It's taken that long for our technology to catch up to his brilliance and confirm the theory. Scientists suspect that two merging black holes emit more energy in the form of gravitational waves in the last few minutes before they collide than a single star emits over billions of years. Gravitational waves contract and expand the fabric of space-time, but only by a very small amount. Gravitational waves allow us to detect for the first time when two black holes are about to collide. The signal that LIGO scientists discovered from such a collision released 50 times more energy in the form of gravitational waves than all of the power put out by all of the stars in the universe put together.
Good morning everyone. Today our topic is stories of space from 7th century to 21st century, done by Sanjay Ishan Tarun Babu Parnita. The beginning of astronomy. As the stars move across the sky, each night people of the world have looked up and wondered about their place in the universe. Throughout history, civilization have developed a unique system for ordering and understanding the heavens. Babylonian and Egyptian astronomers developed systems that became the basis for Greek astronomy, like socialities in the Americas, China, and India developed their own. Ancient Greek astronomers worked in richly documented in the collections of the Library of Congress. Some thought that space was divine. Some said that space was just an empty void, while some argued that space was continuously filled with matter.
Hello all, my name is Padmita and today I'll be speaking about Galileo Galilei. Galileo Galilei was an Italian astronomer and engineer and is called the father of modern science. Galileo was born on 15 February 1654 in Pisa, Italy. He discovered Ganymede, Europe, Lo, Castello and rings of Saturn. Galileo work also in the foundation for today's modern spacecraft and telescopes. Galileo Galilei's greatest discovery was the Earth that revolves around the Sun. But Galileo was responsible for several other major discoveries in the field of physics and motion. Galileo preserved the use of telescope for observing the night sky. His discoveries undermined the traditional ideas about a perfect and unchanging cosmos with the Earth at the center. Thank you.
Good morning, everybody. I am Ishan Ranjit of 9A and I am going to be explaining about Isaac Newton and Edmund Halley. Isaac Newton was born on 25th December 1642 in Woolsthorpe, which is in Grantham in England. He was one of the first people to speak of absolute space and absolute time, to distinguish these entities from the various ways by which we measure them. From antiquity to the 18th century, contrary views which deny that space and time are real entities maintain that the world is necessarily a material plenum. Space is nothing but an abstraction we use to compare different arrangements of the bodies constituting the plenum. Newton defined the true motion of a body to be its motion through absolute space. Einstein said that space and time weren't absolute, while Newton said that they were, as it required to prove his theory of gravity. Edmund Halley. He was an English astronomer and mathematician, born in November 8, 1656 near London. He became the first to calculate the orbit of a comet, arguably the most famous comet of all today. Comet Halley, in his honor, it was named. This was an important discovery as during Halley's time, comets were thought to pass only once through our solar system. In 1705, he published a famous book called Synopsis of the Astronomy of Comets.
Hello everybody, I'm Sanjay of class 9A and I'm going to be continuing the story. Albert Einstein. Albert Einstein was a German-born theoretical physicist, widely acknowledged as one of the greatest physicists of all time. Einstein is famous for developing the theory of relativity. He also discovered that energy and mass are interchangeable. Einstein was awarded the Nobel Prize in 1921 for his services and contributions to theoretical physics. Without Einstein, we wouldn't understand space the way we do today. Let us move on to Stephen Hawking. Stephen Hawking, born in Oxford, England in 1942, was an English theoretical physicist, cosmologist and author. He is mainly known for his contributions to the theory of black holes. His contributions towards black holes includes the discovery of the Hawking radiation, now named after him. Hawking's discoveries about space were mainly focused on black holes. He proved that inside a black hole, Einstein's equations break down and a new quantum theory of gravity is required. He is also a well-known author and has published several books based on his ideas about space. The Brief History of Time and The Theory of Everything are some of his most famous books.
Hi everyone, my name is Abhilash. I am here to talk about the topic religious space related. You all might think, what is there to speak about this topic? But there are many things explained about universe 10,000 years ago by our rishis in Vedas and Puranas, which were rediscovered and proven by scientists in later years. Rishi said in Rig Veda that the sun has tied the earth and other planets through attraction and moves them around itself as a trainer moves newly trained horses around itself holding their reins. Earth has hills and mountains in shapes of peg. It still rotates. Sun never sets. All parts of earth are not in darkness. Earth rotates in two ways. First, it rotates on its axis, and secondly, it revolves around the sun. The Aryan said Earth is in spherical shape, whereas Greek believed it as flat. It took more than 2000 years for the Western science to realize the Earth is round. The Indians of 5th century calculated the age of Earth as 4.3 million years, and the scientists in 19th century said it was 100 billion years. In Vishnu Purana, it is mentioned that the days and nights are distinguished when Earth moves on its axis and seasons change when it revolves around the sun. Rigveda revealed that galaxies light up the distant universe for us, which contains about 1 lakh million suns. From here, my friend Shivaguru will continue.
Hello, my name is Shivaguru and I am going to continue after Abhilash. Vedic cosmology on the evolution and rotation of stars. In Rig Veda, it is mentioned there are suns in all directions, the night sky full of them. In Samaveda, it is mentioned that nothing in the Brahman is immovable. In 1920, astronomers came to know that the Milky Way galaxy is not alone in space. There are other galaxies visible to the naked eye and powerful cosmetic equipments. Astronomy and religion have long been closely intertwined, particularly during the early history of astronomy. Astronauts and cosmonauts and spaceflight participants have observed their religion while in space. Astrolatry is the worship of stars and other heavenly bodies as deities or the association of deities with heavenly bodies. The most common instance of this are the sun god and the moon god in polytheist system worldwide. Constellations. The ancient Hindu sage divided the zodiac into 27 nakshatras or lunar constellations. One tradition related to the stars is the Western zodiac made up of 12 constellations: Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpio, Sagittarius, Capricorn, Aquarius, and Pisces. According to Greek mythology, the Orion constellation is named after Orion the hunter. Cancer represents the giant crab that attacked Hercules as a punishment for killing his family. The constellations Virgo is often said to personify Persephone, the daughter of Demeter, the harvest goddess. Thank you. This was a project by Abhilash, Ragasujana, me, Shivaguru, and Srivatsan.
This is not a wormhole. It's much more complicated.
Me and my friends will try and explain to you in simple terms the complex concepts of wormholes.
Let's begin by showing you the effect a celestial object has on space. As you can see, the denser a celestial object is, the higher the impact it has on distorting space. This leads us to a better understanding of the subject.
Figure 1 is an illustration of the perfectly curved space. This is how it actually looks like, although this is not how we usually perceive it. Imagine that an object has to travel through space from point A to point B over the curvature of space. Instead of taking the usual path, a wormhole can help it reach its destination in no time through the shortest distance. In physical terms, it is the difference between distance and displacement.
We have seen the Einstein-Rosen bridge in the movies like Thor and the chartbuster Interstellar, but do they really exist? Right now, they only can exist as a model in a piece of paper.
Great scientists like Einstein have proposed through their theories the existence of wormholes, but we have seen them only in science fiction movies till now. Maybe there will be a day when scientists can show its existence. Only time can tell. Or can it? We are even bending that now.
As you can see in the quick presentation you've put in place, wormholes are for now theoretical things that make sense in paper, but not so easy to create one. Now let me explain now, we are pretty far away from creating a wormhole since we cannot build a large enough hadron collider that can collide particles fast enough to compress mass to a point it actually tears through space-time itself, and we have to do this in the middle of space. So that's pretty hard, and they're not naturally occurring, and even though wormholes kind of are pretty similar to black holes. They can't have an event horizon, or the gravity of it will crush any humans that go near it. Now, when you hear a black hole, you might think, when you hear or a wormhole, you might think it's a two-dimensional circle. But since we live in a three-dimensional universe, anything we perceive is actually in three-dimensional. So a black hole or a wormhole will actually be seen as a worm sphere or a black sphere. It'll actually look as a sphere. And since we're nowhere close to creating one, or even finding any wormholes in real life, I've created a quick render to show you how it would be if we ever go through a wormhole or even get close to one. Enjoy.
Hello everyone, this is Anushka from class 9 and I'm going to talk about the topic revolution. Copernicus discovered that a solar system is called a heliocentric model, which means that is a sun-centered model. This means that all 9 planets revolve around the sun. Revolution is a movement of one body in space around another body. The path of a body follows is called its orbit. Johannes Kepler then discovered that the planets actually travel in elliptical orbits. He also proved that the Sun is not the exact center of these orbits, but it is actually off to one side of their paths.
Hello, this is Srichen from class 9. I'm going to talk about Mercury revolution. The average orbital distance of Mercury is 58 million kilometer, that is 36 million miles. It has shortest year, a revolution period of 88 days, and receives the most intense solar radiation of all the planets. Traveling through space at nearly 29 miles, 49 kilometers per second, faster than any other planet, Mercury spins slowly on its axis and completes one rotation every 59 days. Its temperature is 800 degrees Fahrenheit, 430 degrees Celsius during the day, and 290 degrees Fahrenheit and minus 180 degrees Celsius at night.
Venus revolution. Venus revolves in a circular orbits around the Sun once every 0.615 Earth years or once every 224.7 Earth days. Venus travels at an average speed of 78,341 miles per hour or 1,26,077 kilometers per hour in its orbit around the Sun. No planet approaches closer to Earth than Venus. At its nearest, it is the closest large body to Earth other than the Moon. Earth revolution. Earth orbits the Sun at an average distance of 149.60 million km, and one complete orbit takes 365 days, one sidereal year, during which time the Earth has traveled 940 million km. This extra quarter day is responsible for our leap year every 4 years. The Earth's revolution not only affects but actually causes the temperature conditions that gives us spring, summer, fall and winter seasons.
Hello everyone, it's Ovia from class 9. Mars revolution. The time of revolution the planet Mars takes is approximately 687 days. The planet travels 9.55 astronomical units, in doing so making the average orbital speed 24 kilometers per second. Mars consists of minerals containing silicon, oxygen, metals, and other elements that make up rock. The surface of Mars is primarily composed of thallitic basalt, although parts are more silica rich than typical basalt and may be similar to andesitic rocks on Earth or silica glass. Jupiter's revolution. The fifth planet, Jupiter, takes up to 4,332.8 days for its revolution. This planet can be used to fill 1,321 Earths inside of it. Jupiter is predominantly made up of hydrogen, nearly 10% is composed of helium. A very small fraction of the atmosphere is made up of compounds such as ammonia, sulfur, methane, and water vapor. Saturn's revolution. With an average orbital speed of 9.69 kilometers per second, it takes Saturn 29.457 Earth years or 10,759 Earth days to complete a single revolution around the Sun. Saturn takes a long time to revolve around the Sun because the further away the planet is from the Sun, the larger the orbit path. It can fit exactly 764 Earths inside it. Saturn is predominantly composed of hydrogen and helium, the two basic gases of the universe. The planet also bears traces of ices containing ammonia, methane, and water.
This is Sophia from class 9. Uranus revolution. Uranus orbits around the Sun once every 84 Earth years or 30,687 Earth days. Uranus travels at an average speed of 15,290 miles per hour or 24,607 kilometers per hour in its orbit around the Sun. Uranus is one of the solar system's four gas giants. Uranus is slightly larger than Neptune. Uranus's diameter is slightly lesser than half the diameter of Saturn and Jupiter. Neptune revolution. Neptune orbits around the Sun in about 165 Earth years or 60,190 Earth days. Sometimes Neptune is even farther from the Sun than dwarf planet Pluto. The planet travels a huge distance to complete just one orbit. Neptune's average distance from the Sun is 30.07 astronauts or 4,498,253,900 kilometers. A day on Neptune is just 16 hours long.
Hello, this is Chen from class 9. I'm going to talk about Pluto revolution. Pluto takes 248 Earth years to make one revolution around the Sun. That means 1 year on Pluto is about 248 years. Pluto takes 6.5 Earth days and nights to rotate. So 1 day of Pluto is about 6.5 days and nights on Earth. Scientists have found other objects like Pluto that are called dwarf planets. Pluto covers to 4.74 km per second, 10,603 miles per hour, or a period of about 247.92 years. Pluto's orbit is also highly inclined. This means that it doesn't orbit within the same plane as the rest of the planets of solar system. Instead, Pluto orbits at an angle of 17 degrees.
The members of the group Planets Revolution are Anushka, Sricharan, myself Ovia, and Sai Supriya. Thank you.
Hello everyone, I'm Siti Preeta Ovian of class 9B. A warm welcome to you all to this project presentation on planet rotation by Siti Preeta Ovian, Vibhoth Rabanan and NS Srishant. As a part of this project, we have studied planet rotation and put together a presentation that can give you an overview on key aspects relating to planet rotation like rotation types, axial tilt, rotation period, and why do planets rotate. Now let us get into the crux of this project and discuss the details.
Let us look into what is planet rotation. Planet rotation is the spinning of a planet on its own axis. Axis is nothing but an imaginary line that runs through the center of each planet as depicted in the moving images. There are two types of planet rotation, prograde and retrograde. Prograde rotation indicates that the motion is in the same direction as the Sun's rotation, which is counterclockwise. Planets such as Mercury, Earth, Mars, Jupiter, Saturn, Neptune prograde. Retrograde rotation is the opposite of that, which is clockwise. Venus and Uranus are the only planets that retrograde. Now let us look into rotation period of planets and also their axial tilt. What is rotation period? Rotation period is the time taken for one rotation around a planet's axis to occur. Each planet has a different rotation period. The rocky planets such as the Mercury, Venus, Earth and Mars have much slower rotation period than the gaseous planets such as Jupiter, Saturn, Uranus and Neptune. Jupiter has the fastest rotation period with approximately 10 Earth hours and Venus is the slowest with 243 Earth days for one rotation.
You can see this visibly in the moving image where the rotation of Venus is very slow that it appears almost not moving. What is an axial tilt? Axial tilt is the angle between an object's rotational axis and its orbital axis. Due to various reasons, each planet has a different axial tilt. For example, Uranus was likely hit by a very large planetoid early in its history, causing it to rotate on its side 90 degrees away from its orbital motion. Thank you.
Hello all of you. I am Vibhuth Ramanan of class 9B. Today I am going to explain about why planets rotate and why different planets have different rotational periods. If planets do not rotate, one side of the planet will always be bright and the other side will always be dark. To balance such potential difference, the planets rotate about its axis. Different planets have different rotational periods because each planet has different mass and different distance from the sun. The rotational inertia of an object depends on its mass. To know more about this, we need to know about Newton's law of universal gravitation. The law states that the size of the gravitational force is proportional to the mass of the objects and weakens as the distance between them increases. So planets which are farther from the sun have different rotational period. Thank you.
My name is Srishan and I am studying in class 9A. Today I am going to talk about facts about planet rotation. First fact is Earth is our home. It is nearly 1.5 billion kilometers from the sun and it is the fifth largest planet in our solar system. So second fact is the two main motion of the Earth are rotation and revolution. The Earth spins on its axis from west to east. The spinning of the Earth around its own axis is called rotation. Fourth fact is the Earth takes about 24 hours to complete one rotation. During the rotation, fifth fact, during the rotation of the Earth, one half of the Earth faces look at the sun and the other half is always from the sun. The part that faces the sun directly has the day, and other part away from the sun is the night. Day and night follow each other as Earth rotates on its own axis in 24 hours. The speed of the rotation at any point along the equator is 1671 kilometers per hour and decreasing to 0 at the pole. So this is a diagram. The sun's rays which falls on the one side of Earth is day, and the rays which do not fall on the other part is called the night. Thank you.
Planets and Orbits by Group 13. This is done by Akash, Anish Kumar, Harsh Krishna and Ritik Raj.
Introduction of orbits. In physics, an orbit is the gravitationally curved trajectory of an object, such as the trajectory of a planet around a star or a natural satellite around a planet. Normally, orbit refers to a regularly repeating trajectory, although it may also refer to non-repeating trajectory. To a close approximation, planets and satellites follow the elliptic orbits with the center of the mass being orbited at a focal point of the ellipse as described by Kepler's laws of planetary motion.
For most situations, orbital motion is adequately approximated by Newtonian mechanics, which explains gravity as a force obeying an inverse square law. However, Albert Einstein's general theory of relativity, which accounts for gravity as due to curvature of spacetime, with orbits following geodesics, provides a more accurate calculation and understanding of the exact mechanic of a orbital motion. There are 6 types of orbits that are geostationary orbit, low Earth orbit, medium Earth orbit, polar orbit and sun synchronous orbit, transfer orbits and geostationary transfer orbits, Lagrange points.
Planet. A planet is a large object such as Venus or Earth that orbits around a star. Planets are smaller than stars and they do not produce light. Jupiter is the biggest planet in the solar system. Planets are shaped like slightly squashed ball called spheroid. There are three types of planets: inferior planets, inner planets, and outer planets. Inferior planets. Planets whose orbits lie within the orbit of Earth. Inner planets. A planet in the solar system that have orbits smaller than the asteroid belt. Outer planets. A planet in the solar system beyond the asteroid belt and hence refers to the gas giants.
My name is Anish Kumar. I am from class 9A. I am going to say about the planet types. There are 4 planet types: gas giant, super earth, Neptune like, terrestrial. So, a gas giant is nothing but a giant planet composed mainly of gas. Super earth is nothing but a potentially rocky world larger than Earth. Neptune like is nothing but gaseous worlds around the size of Neptune. Terrestrial, a rocky world outside our solar system.
Hello everyone, this is Niyati.
This is Subhitra Shri.
This is Amrita Arshini, and now we are going to have a general conversation about spinning habitats.
Niyati, have you heard of something called spinning habitats?
Oh yes, I've heard of it. Spinning habitats are fictional. They are a more advanced form of living quarters than a space station or habitation module. It is intended as a permanent settlement or green habitat rather than as a simple waste station or other specialized facility. No spinning habitat has been constructed yet, but many design concepts with varying degrees of realism have come both from engineers and from science fiction authors.
Oh, that's nice. Well, every creation has a reason. Why do you think spinning habitats should be created?
Well, there are a range of reasons for spinning habitats to exist. Besides human spaceflight, supported space exploration, space colonies is an often mentioned particular reason which can be based on reasons like for the survival of human civilization and the biosphere in case of any natural disaster on Earth. It can be either natural or man-made. And we can find huge resources in space for the expansion of human society, and we can expand without any ecosystems to destroy or indigenous peoples to displace, and it could help the earth by relieving population pressure and taking industry off earth.
Wow, I didn't know there were these many reasons to justify why a spinning habitat should exist. What do you think the advantages are?
So I think I know a few advantages. So solar energy is found in abundance in space, and this energy can be used to produce electricity from solar cells or heat engine based power stations, process ores, and provide light for plants to grow and to warm space habitats. Another advantage is that Earth to spinning habitat trade would be easier than Earth to planetary habitat trade, as habitats orbiting Earth will not have a gravity well to overcome to export to Earth and a smaller gravity well to overcome to import from Earth. I've heard that a 1974 estimate assumed that collection of all material in the main asteroid belt would allow habitats to be constructed to give an immense total population capacity. Using the free floating resources of the solar system, this estimate extended to the trillions.
Most asteroids have a mixture of materials that could be mined, and because these bodies do not have any substantial gravity wells, it would require low data. There is estimated to be enough materials in the main asteroid belt alone to build enough spinning habitats to equal the habitable surface area of 3,000 Earths. These habitats may be supplied with resources from extraterrestrial places like Mars, asteroids, or the Moon. One could produce breathing oxygen, drinking water, and rocket fuel with the help of ISRO. It may become possible to manufacture solar panels from lunar materials. If a large area at the rotation axis is enclosed, various zero-G sports are possible, including swimming, hand gliding, and use of human-powered aircraft. What if a space habitat can be the passenger compartment of a large spacecraft for colonizing asteroids, moons, and planets? It can also function as one for a generation ship for travel to other planets or distant stars.
All this sounds really cool, but it would require a lot of resources to be implemented and it would need some requirements. Niyati, what do you think the requirements are?
Personally, I feel like the requirements for a space habitat are many. They would have to provide all the materials needs for hundreds of thousands of humans. In an environment out in space that is really hostile to human life. Well, not only humans, but also plants and animal life need air pressure to survive, so they therefore need an atmosphere. Organic materials for food production would also need to be provided at first. Most of these would have to be imported from Earth. After that, many recycling methods can be implemented to reduce the need for imports. Long-term and orbit studies have proven that zero gravity weakens bones and muscles and upsets calcium metabolism and immune systems. Spinning habitat designs would rotate in order to use inertial forces to simulate gravity. Some very large space habitat designs could be effectively shielded from cosmic rays by the structure in air. Sunlight could be admitted indirectly through mirrors in radiation-proof Louvre, which would function in the same manner as periscope. So what I think the requirements are an atmosphere, food production, artificial gravity, and protection from radiation.
Well, the habitat is in a vacuum and therefore resembles a giant thermos bottle. Habitats also need a radiator to eliminate heat from absorbed sunlight. So in this design, convection would raise hot air up, that is towards the center, and cool air would fall down into the outer habitat. The habitat would need to withstand potential impacts from space debris, meteoroids, dust, and a lot more. Most meteoroids strike the Earth, vaporizing the atmosphere. Without a thick protective atmosphere, meteorite strikes would pose a much greater risk to a space habitat. Radar will sweep the space around each habitat, mapping the trajectory of debris and other man made objects and allowing corrective actions to be taken to protect the habitat. So I think that spinning habitats need a way to reject heat and protection against meteoroids and dust.
Niyati, do you have any ideas of examples for spinning habitats?
I've heard of something called Stanford Torus. It is a proposed NASA design for a spinning habitat capable of housing almost 10,000 to 140,000 permanent residents. The Stanford Torus was proposed during the 1975 NASA summer study conducted at Stanford University with the purpose of exploring and speculating on designs for future space colonies. It consists of a torus or donut-shaped ring that is 1.8 km in diameter and rotates once per minute to provide between 0.9 gram and 1 gram of artificial gravity on the inside of the outer ring through centrifugal force. The interior space of the torus itself is used as living space and it's large enough that a natural environment can be simulated. The population density is similar to a dense suburb with part of the ring dedicated to agriculture and farmhouse.
Wow, that sounds really cool. I wish we could live in spinning habitats in the future. Oh no, I got so carried away by the talk that I totally forgot I had to go to my next class. I got to go now. Nice talking to you guys about such an interesting topic. Let's talk about it in the next time we meet. Bye.